Hello students, welcome back. So now I'm going to be talking about histogram. So what exactly is a histogram? Well, it is used to understand the distribution of numerical data. That's what it does. It actually tells you how your values are spread. In other words, how your data is spread and where do most of your data lies. It tells you all that information. So, what exactly is histogram best suited for? Well, when you want to understand the data distribution, for example, you want to see where most of your data is concentrated. Histogram tells you that. Where most of your data is not concentrated, in other words, is sparse. It also tells you that. It also tells you the shape of your data. For example, let's say people give exams and you want to see what most of the students they scored. So it tells you the distribution of your exam marks. Also, let's say you're working in a company and you want to know what is the most money people are making, the salary range. So it tells you all that. It also helps you identify patterns. For example, let's say you want to look at the whether your data has a normal distribution or not. You can determine that by looking at your histogram. Same thing, you can find out whether your data is skewed. You can even find outliers, and you can even determine whether you have multiple peaks. In other words, if it's a bimodal data. Uh, so there is a frequency of value range. So instead of using exact value, what histogram does, it actually groups data into bins, into intervals. So for example, the marks could be between 60 to 70, your marks could be between 70 to 80, and marks could be between 80 to 90. And you try to find how many people are between 60 to 70, between 70 to 80, and how many students scored between 80 and 90. Your histogram does that for you. So when should you use histogram? Well, when your data is continuous and numerical in shape and in nature. And also when you want to see the spread and shape of your data, you want to use histogram. Also, when you care about the frequency, you don't care about the individual point, but you care about the frequency. That's what you want to use histogram. So the first thing I do is import my matplotlib library. I'm also importing my numpy. This will allow me to perform some vectorized operation on my data. So let's say my data is this right here. This could be age of the employees that are working in the company. And then first thing I do, I sort the data, then I print the data after sorting it. And you can see that the data actually goes from 51 all the way up to 74. I want to know like how my data is distributed. So I'm going to use histogram to find this thing out. In this case, let's start with a simple one. Let's start with bin count equal to 2. So you call your hist method. This is responsible for plotting a histogram. Supply your data, supply your bin count right like this. It's going to return a count, bins, and patches. For our purpose, we are interested in counts and bins. Then I render my graph by calling plt.show, and I'm also printing the bins, which would be this value. I'm also printing the count, that would be this value. After I run this, it prints out this right here. Let me decrease the size of the screen so it's a little bit more visible. All right. So what this is telling me that the number, this one right here, 5162.5, this is telling me that the bins, these are coordinates of the bins. So the coordinate of the bin is 51, that would be this one. The second coordinate of the bin is 62.5, that would be this right here. That's what the 62.5 is. The third coordinate is 74, that would be this right here, 74. So by looking at these coordinates, I can tell now like where my data lies. So how many values do I have between 51 and 62.5? The answer is 36. And you can also count over here. This is 36 approximately right here. So this gives you the exact answer. How many values are between 62.5 and 74? That is between here to here. And the answer is 64. So there are 64 data points between those two numbers. So in other words, there are 64 employees whose age is between 62.5 and 74. Now let's prettify this image. Maybe I want to put some edge colors. I want to put some more stuff. I want to change the colors. I want to put something in between. So this way I can separate one histogram from the other one. That's easy too. So in this case, everything is same. I'm specifying my edge color is green. I'm specifying my color as gold. I don't want the blue. I want gold color. And I'm also giving a title. In this case, I'm calling it histogram of ages, and my title is green. Likewise, I'm giving an X label is age, and I'm also giving a Y label as frequency. If you go back on top right here, you will see it has no label. X has no label. Your Y has no label. It has no title. I want to do all that. I want to prettify this picture. And then I'm also giving my tick parameters, colors equal to green, and then I'm rendering the graph, and then everything is same. Now, after I run this, you can see that now my graph, my histogram looks like this. So this actually has a title, histogram of ages, and it prints out this histogram. It displays this histogram, and you can see that each one of the histogram is separated by a green line right here. And now you can see that your data is a little bit more visual, a little bit more easy to understand because you're able to separate one from the other. Okay, an observation about the bin size. Some of you must be wondering, how did you come across this number right here? Well, that's easy. This is the formula that this one uses. Actually, it creates a bin width that is equal to the maximum value minus the minimum value divided by the number of bins. Well, what is my maximum value of my age? My maximum value is 70. I believe it was. Let's just go verify that. I believe my maximum value was 74, right? And my minimum value is 51 for my age. So your bin width is going to be equal to your 74 minus 51 divided by 2. 2 because you want two bins. And the answer comes out to be 11.5. So that is the width of my bin. So what's happening is that it's starting with this number, which is 51, and it adds 11.5 to that, and the answer is 62.5. This is how you get 62.5. Then you add 11.5 to this, and then you get 74. This is how you get 74 over here. So this is how you calculate this bin width. Okay, so the bin starts from the minimum value, which is 51 in this case, and it always increased by 11.5 units. So the bins, they go from 51 to 62.5 to 74. Okay, now let's increase our bin count. Let's say I want my bin count to be 4. So let's do that. So in this case, all I'm doing, everything is same as the top code, except this bin count I'm changing. Okay, I plot this, and now you can see you have 4 bin counts over here, and these are my corresponding bins right here. So in this case, the number of people whose age is between 51 to 56.8 is 6 people. Okay, and so that means 51 to 56.8, there are 6 people whose ages lies between that number. And how many people their age is between 56.8 and 62.5? The answer is 30. So between this and this, there are 30 people whose age is in that number. And same thing with the rest of them right here. You can actually count too, by the way, 51 to 56.8. Let's just go verify that. So 51 to 56.8. Where's my data right here? 51 to 56.8. That would be this right here. And you can see that 1, 2, 3, 4, 5, 6, 6 values. Okay, so it's agreeing with that. All right, so coming back down right here, I got this. Okay, now let's increase our bin size, bin width to 10 now. Maybe I want to have more bin width. So let's run this again. And in this case, you can see that your 10 bin width, and it gives you the bins and the count for each one of them. So how many values are between 51 and 53.3? Well, there's only one value. This is that one value. So you can see that your plot is a little bit all taking a shape of a bell-shaped curve right here. Now let's play around a little bit with this histogram. So I'm importing my NumPy. I'm also setting a random seed, so this way I can reproduce my result. So let's create some random data points. So I want to create some 10,000 sample points, and I want my mean value to be 65, and I want my standard deviation to be 5. So you specify all this right here. And that creates my 10,000 random points. And then I specify my bin count. In this case, I increased it to 100. Then I'm just calling the same function I just called before. Everything is same. And then when you render this plot, you can see that your histogram looks like this right here. By the way, I'm not printing those counts and bins, but you can print it out if you want. So this way you can see your histogram actually has a shape of your bell-shaped curve, and most of your data lies between this value and this value. That is between maybe 58 to maybe 74 or 75. Okay, that's where most of your data lies. It kind of helps you visually see that.